the maximum amount of active material for this plate to be used. The active material, this orange color substance you see here, what that is actually PbO2, which is a lead dioxide. What happens is, during the formation process, an electrochemical reaction takes place and energy is then stored into this active material. This is why through the maintenance of a battery you only have to add water, even though the battery contains sulfuric acid. It's because those electrons in that electrolyte are absorbed and soaked in and stored in this active material. And that was one of the key components that we looked at for the flat plate, because each flat plate, positive plate, is wrapped with a glass mat material. This is a fiberglass material. It is porous, but this formation process that is in place now actually circulates acid through the cells, whereas the earlier formation process did not. Once the glass mat is wrapped around each positive plate, a plate retainer, this black mesh material you see here, is then wrapped around that. The key purpose for each of these elements is to make sure that the active material stays in contact with that positive grid. Then each positive plate has a separator placed over it, and that's the purpose it serves, as a separator between the positive and the negative plate, so as to avoid any shorts occurring inside the cell. So the project trials we wanted to look at were the soak time, making sure that that active material could absorb as much energy and electrons as it could. Currently it's set to 4 hours. We wanted to extend that by 1 hour increments, run trial product, and perform tests on those trial products. The initial results that we've seen so far have shown an increase of 85% to 92% of capacity in 3 cycles. The next thing we wanted to look at was to extend the formation time in selected steps of the profiles of the formation process. What we wanted to do was increase the time span of the high rate steps of the profile. These are steps where a high rate of current is put into the cell. We wanted to back that current off just a little bit and extend the time to make sure again that that active material gets a good formation, absorbs all the energy that it can. The initial results of these tests have also shown a significant increase in capacity. Where we are now at the current status we're looking at, we think a culmination of both of these trials here, if we have a chance to put those together, we'll really see a good increase and be able to meet our goals. Lost resources, again, is time and utilization of equipment. Also the MRR, if an MRR is required by a 3rd cycle failure, the disposition of that MRR results in the loss of another day. And this does not include any additional testing required by the disposition of the MRR. And looking at our data, based on the 2nd and 3rd cycles alone, 50 days worth of testing have been taken in the 6 months that we looked at. Those 50 days have resulted in an accession of $218,000 loss, and that would total about $436,000 per year. So our goals were to exceed the BCI standard requirement and have the flat plate achieve better than 90% on the 1st cycle of the capacity testing, which would create a savings of about 66.5%, would also reduce scrap. That in turn would increase the on-time delivery for the facility and ensure, again, that 100% quality product was going to its customers, and therefore you increase your customer satisfaction, allowing not only InterSys but the local Richmond facility to continue to be competitive not only in the market but as well as in the company, and continue to be the flagship facility for the company. Any questions?
Questions?
I thought your plant opened in about 75.
It actually opened in 1977.
77.
77 years.
With the large amount of lead that you use, is there any leakage into the community?
No, absolutely not. There are very, very strict requirements that are put into place, not only by OSHA, but the EPA as well. And as a matter of fact, a couple of years ago, our EH&S department was recognized in Knoxville, Tennessee, I believe it was, with an award from the EPA, the environmental agency itself, for our ability to make sure that clean water gets put back into the city and things like like that. Our environmental department was nationally recognized with an award.
Good question over here.
What constitutes a cycle?
What constitutes a cycle?
Yeah.
What constitutes a cycle is a battery is selected from a lot that is being produced. It is then put on a 1-hour boost, which is current going in. It is then placed on a discharge test. It is based on a perfect temperature, and the perfect temperature for a battery is 77 degrees. It's based on a 6-hour test. And what you do is you divide the capacity ampere rating by 6, and what you want to achieve is 90% of that. And at the perfect temperature would be 5 hours and 40 minutes. Once that discharge is done, you then have to recharge the battery to make sure you get the complete capacity put back into it. And then it has about a 6 or 7 hour cool down time so that it stabilizes, which is 90 degrees or below. And that's one cycle.
So did your test show whether or not it was a manufacturing problem or a design problem?
So far, our tests have shown that there are actually some improvements to be made in the process itself, process improvements in the formation process.
One more question, Colonel.
The raw products, or the raw material and the products you're producing are all trucked, or do you use that rail line there next to us?
They're all trucked.
All trucked. Okay, thank you very much.